The idea that fires could be started by residual unused electrons emitted from receptacles is largely considered a myth. Let's examine this concept with a critical eye. The notion of electrons lingering in receptacles after appliances are unplugged, accumulating over time and creating an ignition source sounds far-fetched. While a fictitious report might playfully suggest a surge in fires attributed to these residual electrons, with the National Fire Protection Association, or NFPA, warning about homes with high levels of electronic devices emitting significant amounts of electrons, the reality is quite different. However, there could be a fact-based report presented as fictitious, focusing on a rare cause of electrical fires. While the idea of fires being started by residual electrons is largely considered a myth, there have been a handful of documented cases where it has occurred. In 2017, a fire in a California home was attributed to the buildup of unused electrons at a power strip that had been left plugged in for an extended period. The electrons were able to discharge into a nearby flammable material, igniting the fire. This rare occurrence highlights the importance of unplugging electrical devices when they are not in use, particularly in high-traffic areas or where flammable materials may be present. The truth is that electrical fires are complex events with various causes, typically involving faulty wiring, overloaded circuits, or malfunctioning appliances. Here's a deeper look at some of the real causes of electrical fires. Firstly, faulty wiring is a significant culprit. Over time, the insulation on electrical wires can deteriorate due to age, heat, or physical damage. This exposes the bare wires, increasing the risk of short circuits or ground faults. When a short circuit occurs, a large amount of current flows through an unintended path, generating heat that can ignite nearby flammable materials. Secondly, overloaded circuits happen when too many electrical devices are connected to a single circuit. Each circuit is designed to handle a specific amount of current measured in amps. When the current exceeds the circuit's capacity, the wires can overheat, leading to a fire. Extension cords and power strips can exacerbate this problem if they are used to plug in more devices than they are designed for. Thirdly, malfunctioning appliances can also cause electrical fires. If an appliance has a defect in its internal wiring or components, it can overheat or create a short circuit. This is why it is crucial to regularly inspect appliances for signs of damage or wear and tear. Fourthly, loose connections are another common cause. Over time, the connections between wires and terminals can loosen due to vibration or thermal expansion and contraction. This increases the resistance at the connection point, causing it to heat up and potentially ignite nearby materials. Fifthly, using the wrong size of fuses or circuit breakers can be extremely dangerous. Fuses and circuit breakers are designed to protect circuits from overcurrents. If a fuse or circuit breaker with a higher amperage rating than the circuit's capacity is used, it will not trip in the event of an overload, allowing the wires to overheat and potentially start a fire. Sixthly, damage from rodents or insects can also lead to electrical fires. Rodents can chew on the insulation of electrical wires, exposing the bare conductors. Insects can also nest inside electrical panels and equipment, creating a fire hazard. Seventhly, improper use of extension cords is a frequent cause. Extension cords are intended for temporary use only and should not be used as a permanent wiring solution. They should also be rated for the amount of current that will be drawn by the devices plugged into them. Eighthly, water damage to electrical components can create a significant fire hazard. Water can cause corrosion and short circuits, leading to overheating and potential ignition. It is important to keep electrical components dry and to address any water leaks promptly. Ninthly, old or outdated wiring systems are more prone to electrical fires. Homes with older wiring systems may not have the grounding protection required by modern electrical codes. This increases the risk of electric shock and fire. Tenthly, poor electrical work can create a variety of fire hazards. If electrical work is not performed by a qualified electrician, it may not meet safety standards, increasing the risk of fire. It is essential to hire a licensed and experienced electrician for all electrical work. Let's talk about preventing electrical fires. Firstly, regular inspections of electrical systems are crucial. Have a qualified electrician inspect your home's electrical system at least every 5 years to identify any potential hazards. Secondly, replace any damaged or frayed electrical cords immediately. Do not use electrical cords that are cracked, frayed, or otherwise damaged. Thirdly, avoid overloading circuits. Do not plug too many devices into a single circuit. Use power strips with surge protection to protect your electronic equipment. Fourthly, use the correct size of fuses and circuit breakers. Replace any fuses or circuit breakers that have blown or tripped with the correct size. Fifthly, install arc fault circuit interrupters, also known as ASICs, in your home. ASICs are designed to detect arc faults, which are a common cause of electrical fires. Sixthly, keep electrical panels and equipment clean and free of debris. Dust and debris can accumulate inside electrical panels and equipment, creating a fire hazard. Seventhly, use caution when working with electricity. Always turn off the power at the breaker box before working on any electrical circuits or equipment. Eighthly, have a fire extinguisher on hand. Keep a fire extinguisher readily available in case of an electrical fire. Make sure the fire extinguisher is rated for electrical fires. Ninthly, unplug electrical devices when they are not in use. This will save energy and reduce the risk of electrical fires. Tenthly, educate yourself and your family about electrical safety. Learn about the common causes of electrical fires and how to prevent them. Residual electrons from receptacles are not a credible cause of fires. Focus on the real dangers and take steps to prevent them. If you are concerned about the safety of your electrical system, contact a qualified electrician for an inspection. A good electrician can help you identify any potential hazards and make recommendations for improving the safety of your home's electrical system. Understanding electrical safety is paramount in preventing fires and protecting lives and property. While the notion of residual electrons causing fires may be amusing, it is important to focus on the real causes and take appropriate safety measures. It is also important to follow the National Electrical Code, also known as the NEC, and local codes. These codes are developed to ensure electrical installations are safe. The NEC is a comprehensive set of standards that covers all aspects of electrical installations, from wiring methods to grounding and bonding. Electrical codes are constantly being updated to reflect new technologies and best practices. Stay informed about the latest electrical codes is essential for ensuring the safety of electrical installations. The NEC also provides guidance on the proper installation and use of electrical equipment. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding and bonding, and equipment installation. By following the requirements of the NEC, you can help to ensure that your electrical system is safe and reliable. One important aspect of electrical safety is grounding and bonding. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are essential for preventing electric shock and fire. Another important aspect of electrical safety is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. These devices will trip or blow when the current exceeds the circuit's capacity, preventing the wires from overheating and potentially starting a fire. Regular maintenance of electrical systems is also crucial for ensuring safety. This includes inspecting wiring, connections, and equipment for signs of damage or wear and tear. It also includes cleaning electrical panels and equipment to remove dust and debris. By performing regular maintenance, you can identify and address potential problems before they become serious fire hazards. When working with electricity, it is essential to follow safe work practices. This includes turning off the power at the breaker box before working on any electrical circuits or equipment. It also includes using insulated tools and wearing appropriate personal protective equipment. By following safe work practices, you can minimize the risk of electric shock and fire. Here's some general guidelines you should follow. Firstly, always turn off the power at the breaker box before working on any electrical circuits or equipment. Secondly, use insulated tools and wear appropriate personal protective equipment when working with electricity. Thirdly, never work on electrical equipment when you are wet or standing in water. Fourthly, do not overload circuits or extension cords. Fifthly, replace any damaged or frayed electrical cords immediately. Sixthly, keep electrical panels and equipment clean and free of debris. Seventhly, have a qualified electrician inspect your home's electrical system at least every 5 years. Eighthly, install arc fault circuit interrupters, also known as FSIs, in your home. Ninthly, have a fire extinguisher on hand in case of an electrical fire. Tenthly, educate yourself and your family about electrical safety. Electrical safety is a critical issue that should be taken seriously. By understanding the causes of electrical fires and taking appropriate safety measures, you can help to protect your home and family from the dangers of electricity. Remember, when in doubt, consult a qualified electrician for assistance. Electrical work should only be performed by qualified professionals who have the knowledge and experience to do the job safely and correctly. Do not attempt to perform electrical work yourself unless you are properly trained and qualified. Even seemingly simple tasks such as replacing a light switch or outlet can be dangerous if not done properly. By following these guidelines, you can help to ensure that your electrical system is safe and reliable, and that you and your family are protected from the dangers of electricity. It's also important to understand the different types of electrical wiring and their applications. For example, non-metallic sheet cable, also known as NM cable or Romex, is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a plastic sheath. Armored cable, also known as AC cable or BX cable, is similar to NM cable but has a metal armor that provides additional protection. Conduit is a metal or plastic pipe that is used to protect electrical wiring. Conduit is typically used in commercial and industrial applications, as well as in residential applications where the wiring needs to be protected from physical damage. The type of wiring used in a particular application depends on the specific requirements of the installation. Electrical panels, also known as breaker boxes or load centers, are the central distribution point for electricity in a building. The electrical panel contains circuit breakers that protect the circuits from overloads and short circuits. Electrical panels should be properly labeled to identify the circuits that they control. It is also important to keep electrical panels accessible and free of obstructions. Ground fault circuit interrupters, also known as GFCIs, are designed to protect people from electric shock. GFCIs detect ground faults, which occur when electricity flows through an unintended path to ground. When a ground fault is detected, the GFCI will trip, cutting off the power to the circuit. GFCIs are typically installed in bathrooms, kitchens, and other areas where water is present. Surge protectors are designed to protect electronic equipment from voltage spikes. Voltage spikes can damage or destroy electronic equipment. Surge protectors work by diverting excess voltage away from the equipment. It is important to use surge protectors for sensitive electronic equipment such as computers, televisions, and audio equipment. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. Proper grounding helps to prevent electric shock and fire. Bonding is the process of connecting all metal parts of an electrical system together, creating a low impedance path for fault current. Bonding helps to prevent electric shock and fire. In conclusion, while the idea of fires being started by residual electrons from receptacles may be entertaining, it is not based on scientific reality. Electrical fires are complex events with various causes, typically involving faulty wiring, overloaded circuits, or malfunctioning appliances. Focus on the real dangers and take steps to prevent them, such as regular inspections of electrical systems, replacing damaged cords, avoiding overloading circuits, using the correct size of fuses and circuit breakers, installing FSIs, keeping electrical panels clean, and educating yourself about electrical safety. Always prioritize safety and consult a qualified electrician when needed.